Hello everyone, I am Abdullah Arafat, undergraduate student of Material Science and Engineering at Khulna University of Engineering and Technology, KUET. Welcome to the tutorial. So today we will be doing a 2D Lennard Jones crack simulation. So before starting the simulation, let's see what are we expecting as an output. So this is the output. If we go to the time frame, then we can see a crack is propagating through the atoms, right? So to make this, let's go back to the input script. In this tutorial, I will be showing you only the initialization part. So let's start. So before starting the simulation, we need to set the dimensionality of the simulation. Usually the dimension is 3 dimension, but in this simulation, we will be doing a 2-dimension simulation. The default settings of LAMMPS is 3 dimension. So if you remove this part, then LAMMPS will consider the simulation as a 3-dimensional simulation. Now let's come to the boundary. So this boundary means the boundary of the simulation box. So what actually is a simulation box? Simulation box is simply a box in which the simulation will be done. It can be a box or a cylinder, or it can be many shapes. So I have defined the simulation box as S, S and P. That means S in the X direction, S in the Y direction, but P in the Z direction. So what does this S, S and P means? To find it out, let's go to the documentation of LAMMPS. This is the documentation of LAMMPS. Actually, you can consider this as a Bible of LAMMPS, because if you want to work with LAMMPS, then you have to come frequently to the documentation. So let's go to commands and then boundary commands, and here you can see there are 4 types of boundaries for the simulation box. P is periodic, F is non-periodic and fixed, S is non-periodic and shrink wrapped, M is non-periodic and shrink wrapped with a minimum value. So what are these actually means? Let's see. So suppose consider a 2D simulation box. So this is your 2D simulation box. For P, which is periodic, it means that the particles interacts across the boundary and they can exit one end of the box and re-enter the other end. That means this atom, if it goes out of the boundary, then it will be re-entered as this atom. So it can be said that this simulation box is periodically distributed all over the space. Suppose if these atoms goes here, then it will be coming from this side as this atom. This is called the periodic boundary, which is defined as P. Now the F, which is fixed boundary. Suppose this is the X direction and this is the Y direction. Now if you consider that this Y boundary is fixed, then what happens? F determines the position of the face is fixed, and if an atom moves outside the face, it will be deleted on the next time step that reneighboring occurs. So that means suppose this atom goes outside the boundary at a time step, and this is its final position. Then the next time step, as the Y boundary is fixed, this will be deleted by LAMMPS. So if any atom goes outside the boundary, outside the fixed boundary, then that atom will be deleted in the following time steps. So after that comes the shrink wrap. So shrink wrap is the position of the phase is set so as to encompass the atom in that dimension, no matter how far they move. That means suppose this atom in one time step goes here. So unlike the fixed boundary, in the shrink wrap boundary, this boundary will move and come here. And this atom will not be deleted. So the boundary is extending up to the position where the atom moves. That is the shrink wrap boundary. Now the M, which means the boundary will be shrink wrapped but up to a minimum value. So suppose the minimum value is this much, and now the atom moved out of the minimum value, then the atom will be deleted. But if the atom moved inside the minimum value, then the atom will be considered. So these are all the boundary conditions. Now let's go back to the input script. Next, you can see the atom style is considered as atomic. So atom style simply means the style of the atom. So this is the atom style of LAMMPS. As you can see, the atomic style means that is the default value actually. So it will consider the solids, metals, and coarse grain liquids. Similarly, suppose you are working with charged atoms. Suppose you are working with sodium chloride. Sodium is charged, chlorine is charged. So then you will consider the charge atomic style. You can see that the charge atomic style considers the atomic system with charges. Similarly, there are a lot of atom styles you can consider with your needs. So this is it. See you soon in the next tutorial.